commutator value of angular momentum operator. L equal to, we write this Lx I plus Ly j plus Lz k. So L square equal to, we get a Lx square plus Ly square plus Lz square. So Lx equal to y pz minus z py. So Ly equal to z px minus x p z. Now Lz equal to x py minus y p z. Means when Lx, when we write of Lx, the next to x it will be x y z. So we write of Lx will y p z y pz minus this will z and py. When we want to write a ly, so after y it will be z, then px, then x, then pz. Of Lz, after z it will be x py or minus y, then p, sorry, here it will be a x py y here. See, when we want to write a Lz, so x py, now y px, this, and we have to learn this, everything we have to learn this. It's simple, nothing hard. Now linear momentum and position operator, we have the value equal to p y y equal to p z z, means linear momentum with x axis of position with x axis, means with the same axis where we have the value minus I h cross, with same axis we have the value. And second px linear momentum px with x axis and the y equal to py z equal to pz x. So when the linear momentum and the position are with the same axis, so we have the value minus I h cross, and linear momentum and position with the different axis, it commute, the value is 0. Linear momentum and position with different axis, the value is 0, so it is commute. Now third, Lx x equal to Ly y equal to Lz z equal to, see this is a angular momentum denoted by Lx with the same axis x, Ly with the same axis y, Lz with the same axis z. So here the value is 0. It commute, means a linear momentum with the same axis, the value is minus I h cross, and linear momentum with the different axis, the value is 0, means commute. The angular momentum with the same axis, the value is 0, means commute, and the angular momentum with the different axis, it has a value Ly z to Lz x. It has some value, so it is not equal to 0, it has some value. So this we have to learn, and we know that x px equal to I h cross, and when we change the position, px x equal to minus I h cross. this is symmetry, and this is anti-symmetry. And x dy dx equal to -1. When we change the position, dy dx x equal to 1. And second thing, if we raise the power of x raised to n px, so we have the I h cross n x raised to n minus 1. In previous video I have explained same x px raised to n, so I h cross n px raised to n minus 1. See, x raised to n px, the value is I h cross n x raised to n minus 1, and if the x px raised to n equal to I h cross n px n minus 1. When we change the position of this, there will be a minus. When we change the position of this, it will be a minus, because AB equal to minus BA. And we seen that angular momentum with the same axis, the Ly, Y, Lz, Z equal to 0, means it commute. Now I am writing the value. Lx angular momentum with a different axis, Lx, Y equal to I h cross Z, means here Lx and Y we have to write, then equal to I h cross, here is x, y, then here will be z. So like this, Ly z equal to I h cross y z, here will be x. Like this, Lz equal to x equal to I h cross zx, it will be y. And when we change the position, if we change the position, there will be a minus if we change the position, like this. Now for next, Lx py means angular momentum and linear momentum. We have a value I h cross pz, means Lx Ly pz. Like this, Ly pz equal to I h cross y z, it will be x. This Lz px equal to I h cross, here will be a z x y. Like this, we have to learn this value, it's easy. Now next, Lx Ly equal to I h cross x y, value will be a Lz. Like this, Ly Lz equal to I h cross Lx, and this Lz Lx equal to I h cross Ly. And the square of, now the square of angular momentum with the x-axis is 0. So L square with angular momentum with y-axis equal to 0. L square with the Lz equal to 0. We have to learn this, remember this, it's very easy. Now we are moving to a orbital angular momentum. And remember this, if we change the position, if we change this position, then it will be minus. So here orbital angular momentum L equal to total angular momentum Lx equal to x component of angular momentum, like this. Ly is y component of angular momentum, Lz is z component of angular momentum. So we know the value of Lx, Ly value will be I h cross x, y to z. Ly, Lz will be I h cross y, z, Lx. So Lz, Lx equal to I h cross zx till y. So if we change the, now we move to a spin angular momentum. Spin angular momentum is denoted by S. So S is total spin angular momentum. So Sx is a x component of spin angular momentum, like this. Sy is a y component of spin angular momentum, Sz is a z component of spin angular momentum. So here same Sx, Sy value will be a I h cross Sz, like this. Sy S z equal to a I h cross yz, it will be a x, means we are going a x, y, z, like this. Sx, Sy the value will be a I h cross Lz. See Hz. Now Sy, Hz the value will be a I h cross Sx. Hz, Sx equal to a I h cross Hz, Sx the value is I h cross Sy. And if we change the position, suppose if I am changing the Sy and Sx, we know the value of Sx and Sy, I h cross Sz, so just there will be a minus I h cross Sz. Similarly for these two also, if we change the position, the minus will come here. I am writing, if we change the position of operator, then it show anti-symmetry, that is a b equal to minus b a. Now we are moving further. Ladder operator. Ladder operator, in this we seen that a orbital angular momentum and the spin angular momentum. Here we denote by Lx is a raising operator, and L minus is a lowering operator. Like this, here also S plus is a raising operator, S minus is lowering operator. So S L plus equal to Lx plus I L y. So L plus is Lx plus I L y. So L minus will be a Lx minus I L y. Similarly, for a spin angular momentum, S plus equal to Sx plus I Sy, and S minus will be Sx minus I Sy. So let's solve some problem. So L plus and Lz, we have to find the answer. So here L plus Lz, and we know the L plus value is Lx plus I Ly. Here is Lz, and we know this is A plus B and C. So we know AC plus BC. So we will write this like this: Lx Lz plus I Ly Lz. So Lx Lz, to have, you know that the Lx Lz, the value will be I h cross L. So this is x, y and z. Here is x, y, means it is anti-clockwise going. We know the value of Lx Ly. Lx Ly is I h cross Lz, and Ly Lz is I h cross Lx, and Lz Lx to I h cross Ly. And you see this, the position is changed, so it will be minus h cross Ly. So here is, there the position is changed, so it will be a minus h cross Ly. Means you can see this x z, means it is reverse, so minus h cross Ly. You can, simple way, we know this, Lx Ly is I h cross Lz, Ly Lz I h cross Lx, Lz Lx equal to I h cross Ly. Just write this simply, and we see we have the value of Lz and Lx, and you see this, it is just a position change. So by the change in position, we have to write a same value and write a minus here. So I have written here minus I h cross Ly plus, and here is the I is constant, so we can take outside, because it is a commutator rule. Ly Lz, I have told you in the first video that Ka B, we can take a K common, because K is a constant. We can write like this. This is a property of commutator. So now I h cross Ly plus I, and here is Ly Lz, so I h cross Ly Lz, here will be Lx equal to I h cross Ly. This I will be a I square h cross Lx, and we know that I value is root minus 1 and I square is a minus 1 value. So just substitute here I h cross Ly minus 1 h cross Lx. Now just to take a common h cross, so we get a I Ly minus Lx. So we get a h cross, and this is a I h cross I Ly minus Lx. Now we know the value. Here is, oh, we have missed this minus here. Minus will be here, minus, minus, and the just we will take a minus to common here, so it will be plus, minus. We have missed the minus sign here, sorry, minus h cross. So the value is lx plus I ly, and we know the value of this is the minus h cross l plus. Like this you can find further. For we have got a l plus lz is minus h cross l plus. If we change the position, lz l plus, the value will be a h cross l plus. L minus lz we are solving, so we know the value of L minus is lx minus I ly. This is lz, and this is a minus b, and this c. So we know that bc minus bc. Similarly, like this, lx lz minus I ly lz. So lx lz, here see x y z. So here is x z y, it is moving anti-clockwise, so minus I h cross l y, because we know the value of lz lx is I h cross ly. Here the change in position, so it will be a minus will come, and the remaining the part will be, the answer will be same, I h cross ly minus. Now I is the common, this I is a constant, so we remove outside, ly lz equal to minus I h cross ly minus I ly lz will be a I h cross lx. We know the value of ly lz is I h cross lx. So just minus I h cross ly minus I square h cross lx. So taking minus common, minus common, so I h cross ly plus I square h cross lx. So we know the I square value is minus 1, so writing minus I h cross ly minus 1, substitute the value of I square, so minus 1 h cross lx. So minus I h cross ly minus h cross lx. So taking h cross common, so we get a I ly minus lx. Now multiplying this y inside, so we get a h cross lx minus I ly, and we know the value of this, it is of l minus lx minus I ly, we know. So it value will be a h cross I minus. So we know the l minus lz, the value is h cross l minus, and if we change the position, lz l minus is minus h cross l minus.